me know when you're ready.
Yeah.
You press the red button. Already? It's recording?
Yes, it's recording.
Because we don't want the same thing that happened with Leo.
Okay, everyone pay attention now. It can be a bit tricky, I understand, okay? So please pay attention. Now, you begin from n equals 2. Can somebody tell me why n equals 1 is not included?
Because it doesn't work.
Why? Can you see why it doesn't work? Because when it is equal, not greater. If the question was greater than or equal, then maybe n equal to 1 would be the beginning. Please pay attention. So, when you have n is 2, you are supposed to, okay, Pn is the statement 1 minus a to power n greater than 1 minus na. That's your Pn. So P2 will be 1 minus a to power 2, which is equal to 1 minus 2a plus a squared, right? Which is definitely greater than 1 minus 2a, because this is a positive term. It's a positive number. No matter how small a is between 0 and 1. When you square a fraction, you still get a positive number anyway. So this as an additional positive number, it will be greater than when it doesn't have the additional positive number. And this is what you want to show for the n is equal to 2. Does it make sense now? So we assume, please pay attention. So we assume Pk is true. What does this mean? 1 minus a to power k will be greater than 1 minus ka. Right? Now we show when n equals k plus 1. That's what we want to show. So, I write somewhere my objective. My objective is this. I want to show that 1 minus a to power k plus 1 must be greater than 1 minus k plus 1 a, isn't it? Talk to me, please.
Yes.
That's my goal, right? What is this? This is 1 minus ka minus a, right?
Yes.
If I can achieve this, I'm okay. You can see I didn't put it in my book. I put it somewhere to guide me. That was the trick he used. He expanded this, then he's trying to see how he could walk towards it sensibly, logically, not just because you want to get there. There must be a reason why you should achieve that. So, 1 minus a, so I start with the left-hand side, of course. So I don't need to put that. K plus 1. This is equal to 1 minus a to power k, then 1 minus a to power 1. Agree? Now, this already is greater than this. Hello? This is greater than this. It means the product must be greater than 1 minus ka times 1 minus a. Do you agree? Do you agree? Any question? Now, this is going to be equal to 1 minus a minus ka plus a squared. No, k is a squared k, like that. Do you agree? What do you notice? Can you see that? That's all I need, right? But I don't have, I have my greater. So this is greater than this, definitely. But can it also be greater? This already is going to be greater than, do you agree? It's going to still be, I'm saying this is bigger than this. That is, this one is going to be less than this. That's the meaning of this inequality. Do you agree with that? And this is what I need. What is the reason why this can be removed? Anyone?
Because it's not like an equation. So
No. Why can I, because I just wrote the same thing ignoring this one. Why do you think it makes sense to remove this to achieve this greater? Why is this expression greater than this expression?
No, understand.
Speak louder. I'm adding a positive. This term that is being ignored is positive. K is positive. A squared is positive. The product of positive and positive is positive. So when you add a positive term, it's definitely greater than when you do not add the positive term. That's what we are talking about. So we have used the same technique twice now. We use the same technique here. Does it make sense? So, if this is now, so finally we said this is equal to this, which means this is greater than this. Alright? And this is equal to this. Now this equals to this means this is still greater than this. Do you agree with that? I'm only connecting the lines. If I'm going to repeat this all the time, I will maintain greater than. What I'm saying is, this step is equal to this step. But because this is greater than this, then this is also greater than this because they are equal. Do you understand that? Now, this step is greater than this step. Now, if this is greater than this, and this is greater than this, then you agree this is also greater than this. Do you understand the logic now? Okay? So, what does that tell us in essence? It means 1 minus a to the power k plus 1 is greater than, so I'm going to factorize. If I factorize a out, what do I get? 1 plus k, right? I want it to look like this. All I need to do is take the a back, which does not make any difference, right? And change 1 plus k to k plus 1. And I achieve my result. Okay? So which means 1 minus a to the power k plus 1 is greater than 1 minus k plus 1 times a. And this is what we want to achieve. So this shows that pk plus 1 is true. Then the statement is true for all n. Any questions? So write your conclusion. Don't forget, this is positive. And the same thing happens here. It is positive. We use the same technique. That term is positive. When you write the expression without the positive term, the first one is meant to be greater than the second one. Okay? So please try the next inequality. Let's take 5 to 10 minutes also for that.